Hello girls and boys, welcome to another week of Science in Mrs. B's Kitchen. I'm really excited this week. We've got some really fun activities. We're going to be making some butter, making salt, or kind of making salt, watching water crawl, and looking at some fun activities with water and different things. Now first of all, I just want to show you what I found in my garden yesterday. A mango. Well, I knew I had a mango tree, but I didn't know this mango was still on it. Look at the size of it. Now mangoes normally are grown in hot climates and they're normally available around December, January, February. But this is now May, and that just shows you we're a lot further south than when mangoes are normally grown, and it takes that much longer for my mangoes to grow to the right size and to ripen. It's not quite ripe. In a few days, I think it's going to be perfect, so I'm really excited about that one. However, what I wanted to show you this week, first of all, was a reaction. Now, this is not a glass of wine. No, it is actually some oil, just some cooking oil and some water. Now, Miss Porteous showed me this experiment. I'm going to put some red food dye in it. Just about. Now, if you look very carefully at the red droplets, they are falling down through the oil and they're sitting on top of the water. So it's quite interesting. I can just see them underneath popping down below, but they're keeping their shape, the little round shape, except for that drop that I kind of put down the side. So what I'm going to do, boys and girls, I'm going to add an Alka-Seltzer tablet. Now this has got bicarb soda, but also citric acid in it. Anyhow, we're going to look at that reaction of when it gets in the water, they're going to combine together and they're going to create a reaction. So let's just drop them in and see what happens. See all the bubbles that are forming? That just shows the effect of the carbon dioxide reacting in the oil and how the gases are in the oil, because they obviously can't escape and get out, so they're going crazy there through the oil. So this week, boys and girls, what we're going to do is we're going to first of all go over what we did last week, because in your quiz I've got a few questions there from last week still, because I'm hoping you remember some of the things that we did. So we're going to have a look at the word wall now and see exactly what we did last week, and then we're going to talk about what we're going to do today. So last week we talked about mixtures and we talked about heterogeneous mixtures, and we said, and we showed how that we can use a magnet to separate some mixtures, and we also used the sieve to separate mixtures as well. Now both of these type of mixtures were solids. We separated solids from other solids. Then we had a look at solids that were mixed with water. So we used sedimentation. Remember, we had sand and it sank to the bottom and we separated the water, and then the water still had a bit of sand in it. So then we used the filter paper to get those really fine particles out. So that was called filtration, which is with a solid and a liquid. And then the last one we looked at was two liquids, decantation. We looked at two liquids that had different densities. So we had oil, and we separated that from the coloured water. And I was able to just stop it in time before the oil came through, because oil is less dense than water. So that's how we separated it. Now these were all heterogeneous mixtures, meaning that we could see the particles in them beforehand and they weren't evenly dispersed. But this week we're going to be looking at the other type of mixtures that we talked about, and that is homogeneous mixtures. Now, homogeneous mixtures are when all the particles are really mixed closely in together and you really can't see them. So today we are going to be looking at evaporation as a way of separating different elements in mixtures, distillation and chromatography, and a couple of other things there too, which I think is kind of interesting. So we're going to look at those and see how we can separate these mixtures. The learning intention today, boys and girls, is for us to understand that homogeneous mixtures can be separated into different substances, and often those substances are more useful than when they're mixed together. Now the first thing we're going to do is we're going to mix some hot water and some salt. I've got some hot water here, and I'm going to mix it with some salt. Now I'm going to put a fair amount of salt in because I want to really show you what's going to happen. This is just going to create salt water, of course. Salt water obviously in the sea is not going to be like this, but I'm making it extra salty. But I'm going to dissolve it all up. You can see the water's got a bit of a whitey opaque type colour. It hasn't quite dissolved yet. I'm just waiting for it all to dissolve. Okay, that's all dissolved. I'm going to put it on the stove now, and I'm going to use evaporation to get the water out of there and leave the salt behind. And that's how we get all our salt from the sea. They have large areas where they spread the water out, and it generally evaporates by the sun actually. Over in South Australia and Victoria and those places, they've got very big salt making areas. And it's really interesting to see that they just use nature to separate. And evaporation, as you know, occurs all the time outside. So, but we're just going to speed it up in my kitchen today to show the same effect. I'll just turn it on to a high temperature. And it'll just take a little while, and we'll get back to that in a moment. In the meantime, boys and girls, what I want to do is also, I want to look about how water can crawl. Yes, water can actually move. Let's see how we can do this. I've got some cups here with water in it. Now I'm going to put some dye in the different ones. I'm going to put red, blue dye here, yellow dye here, that around to there. And what I've done also is I've got some paper towel that I've folded up, and I'm going to put that in between these like this, and we're going to watch these containers fill up with the liquid, because the liquid is going to crawl from one cup to the next. So I'll put that in there, this in here. Alright, now that's going to take a little while. As we can see, boys and girls, we can already see the effect of that water is crawling up against gravity. And you know what that's called? It is called capillary action. That's another interesting word, the capillaries. They are moving up there through the paper towel and it's going to be moving over into the other cup. I'll just leave that there for the moment while I can hear the water boiling on the stove now. I'm wondering how that salt water is going. Well, boys and girls, the water has completely evaporated, as you can see, and all I've got left is salt. Also all over my stovetop as well. So I'm going to scrape that out now and show you that we're able to separate the homogeneous mixture to get out a product now that is useful to us. Just going to get that salt now that's all over the saucepan and put it out on the plate here. Now it's just completely dry. It's a bit softer actually and fluffier because it's a bit stuck together, but that's okay, because you know what, I'm going to use that later because I'm going to make some butter, add a pinch of salt, and I've got my little bread over here. I'm going to make my own butter with salted butter and put it on my bread because I'm going to be hungry later, I can tell. That was evaporation, and you use it when you're separating a solid from a liquid. However, a lot of the time you just have liquids that are mixed up. And with that process, we need to use distillation. Now, this is a distillation system. I am not doing that because I'm not a proper scientist and haven't got a proper science lab. But to do distillation, what you need to do is heat the liquid up, very similar to evaporation, so that the heat and the gases come off, but then you collect those gases. We didn't collect that water that evaporated, it just went into the air. But what they do is they collect the gases and it goes into a long tube and it cools. And at different points of when it cools, it forms different products. So we've got evaporation and distillation. And in the oil industry, crude oil comes from under the ground and then it gets sent to the refineries. And at these refineries, it gets heated up into these huge distillation towers. At the very top of that, gases come off and they collect that for gas. Then after that, aviation fuel, it's very light, it goes in the aeroplanes, that comes off as well as the next layer. And then the next layer down could be petrol, or maybe, and then after that, distillate comes out of there. Even kerosene comes from oil originally. And then after that, all the oils and things that your father or mother might put in their car to keep it running smoothly, that all comes out of crude oil. But they all come from different processes because they've got different heating temperatures where they form a gas. And that's taken off and it's collected. So distillation is very, very important in industry today. As I said earlier, girls and boys, we're going to make some butter. Now, butter, as you probably know, comes originally from a cow. However, years ago when I was a little girl, we used to get our milk delivered in a bottle. It used to come to my front door. That's how old I am. And you could either get homogenized milk, which means the milk particles and the cream are all mixed up, or you could just get the normal milk. And basically at the normal milk, you just had the cream at the very top. Because today, all our milk, most of our milk that we get in our cartons and in those plastic 2-litre containers are all homogenised milk. You cannot see the cream and the fats and the different parts of those milk. So milk is an homogenised mixture. However, we've got some cream here, and from that cream, I'm going to pour it into my mixer here. I'm going to turn it on and I'm going to beat it, and that beating is going to separate the fat part of the cream. So what we're going to have is we're going to have butter and we're going to have buttermilk. So let's see how this happens, and we'll take a little while. So I'll just start it off and then we'll see it turning into butter. Obviously when you first mix cream, it just gets thicker and fluffier, and we use it in desserts and cakes and things like that. So let's just wait a little while and see what happens with the cream. Well, girls and boys, that's been beating for at least 5 minutes and we've now finished it. But as you can see, that cream has now got a yellowy colour because the liquid part has been separated out of it. So that basically is the fat. Butter is, I have to say, fat. So that's probably why it tastes pretty good. So what I'm going to do is I'm just going to get this buttermilk out of there. I mean, if I was making pancakes or something, we could have lovely buttermilk pancakes or nice scones. That would go very nice because it's still a very rich milk, rich in lots of fats. But out of there, as you can see, there's my butter. What I'm going to do with that butter, I've got more on here as well. I'm going to get some more of it off. So they got that lovely butter. I'm going to sprinkle a little bit of salt in, not too much, because salt does make the butter taste really nice. I'm going to mix it in a little bit. See, the liquid's still coming out a bit because so I've made that up into a lovely butter with a bit of salt in it. And I'm going to now put that on my bread. And as you can see, boys and girls, just looks like the butter that you get. It's in your fridge all the time and tastes exactly the same, because that is all butter is. Butter is literally the fat part of the milk from the cow, and with a little bit of salt added. Sometimes I might add something else to make it spread a bit smoother, but that's how they get butter. So it was a homogeneous mixture, and by doing that I was able to separate the fats and the non-fat part. Girls and boys, the last separation I want to talk about today is called chromatography. Now, you probably don't really have to remember that word. However, I've got it on my word wall here just so you can see what it looks like. Chromatography. So it's to do actually with colours and pigments and dyes. When you see a colour, it's generally made up of other colours. As you know, green is made up of blue and yellow. So with chromatography, we are able to identify these things because some of those colours dissolve at different times to others. So we've got here, with a homogeneous mixture, we've talked about evaporation, we've talked about distillation. I've done the beating with the cream to form the butter, which is not on here, but that's just another method of separation as well. But this one is chromatography, and that's to do, even the word tography, it's to do like photography, colours. What we're going to do is we're going to see how we can separate the different dyes or the different pigment colours that are in a dye. So first of all, I'm going to get some paper towel. I'm going to put some black texture, nice big blob of black texture. And on the other, I'm going to put purple. They're both dark colours, so they're both easy to see I think, the colours that are made up of. Now I've got some water here. Now we've talked about our creeping water. I'm going to get back and show you what's happening there in a moment. But in the meantime, I'm going to get these 2 bits of paper and I'm just going to very carefully put them just touching the water, okay? There's one and there's the other, so they're just touching the water. So while we're waiting for that, we're going to watch the colours of the dyes separate, because as I said, different dyes dissolve at different times. Some take a bit longer, some are a bit harder. That's why when you do your washing, sometimes if you get certain stains on your clothes, they're really, really difficult to take out. Now, I'm looking at this purple one and I'm seeing already that it's got some red and blue, which is what you'd expect from purple. So you can see that the colours are moving out of it one at a time. So obviously the red dissolved first. We'll just leave it there a bit longer. Now in black, you think, what's black? It's black, isn't it? However, this black will show that there's a little bit of red in there, but there's mainly a fair bit of blue as well. So this is called chromatography, and it's just getting the pigments of the dyes to separate. As I said before, just watch that, leave it there for a moment. Earlier on, we did the creeping water, and that's the capillary action. That's also using capillary action. So I'll move it back and I'll show you what is happening. So this has just been sitting here while I've been making the video. As you can see, these 2 cups were completely empty before, and now they've got liquid in it. But look at the colour of the liquid. This is green. So it's mixed the yellow and the blue, and the capillary action has brought the water into this dry area. It hasn't gone back, it's stayed in there. It's very, very interesting. Here, capillary action is stronger than gravity. And over here, we've got the red and the blue, which you would normally think would make a purple. The colour's very pale here, but it's just a bit of a murky type of pale reddy colour. Now, yesterday I did this experiment. I used some different food colourings actually, just they were a bit stronger in colour, and I did it on time-lapse photography. So I'm going to try and get that time-lapse photography and put it in the video, which you'll see in a moment, to see how over about an hour or so that liquid moved from one cup to the other. But even still, in the little time that we've been here, probably about, 15-20 minutes, we've seen all that occur. So mixtures are so interesting, and the fact that they form other mixtures, that's what makes it so exciting. Science. Now, well, boys and girls, I just thought I'd bring you back just to have a look at this chromatography, and as you can see, the purple has separated into the blue and the pinky reddy colour, and the black has also got a lot of blue in it as well. So those dyes have been separated, and we now know what makes up those dyes. Now, I think that's about all I wanted to talk about today, boys and girls, but you know what? I've got my milk, I've got my bit of bread and my butter. I'm going to have a bit of a snack. Delicious. That bit of salt just makes it perfect. And I'm going to wash it down with a nice bit of creamy milk. Amazing. It tastes nothing like cream at all. It just tastes like normal everyday milk. I hope you've enjoyed today's lessons, boys and girls, and that you are going to now go on to your Google Docs and Google Forms. Don't forget last week's ones. We got the heterogeneous separations. This week's ones, we got the homogeneous ones. We talked about the evaporation, that was with the salt, a liquid and a solid. Then we had the distillation, which was the different liquids. I didn't show that one, but we talked about the oil industry. And then I've got chromatography, which was about the separation of the pigments of the dyes. Hope you have a great day. Enjoy my science lesson today, and I'll hopefully see you at school the next week. See you later, boys and girls.